Hmm. Hold on.
Good morning.
Good morning. Good morning. No, no. Okay. Now, today we'll start discussing overlap same method. So, overlap same method. Today we'll discuss.
Yes, sir.
Okay. Now, in overlap same method, I've said that first you have to find the right. Yesterday we have discussed overlap add method, and I hope this is all right.
স্যার
Hello?
প্রসেসটা একবার বলে দিন
কোনটা?
এই ওভারল্যাপ সেভ
ঠিক আছে, okay, I'll explain. So in overlap same method, first we have to find the length of the impulse response. Length of the impulse response, what I understand, that we have to find the number of non-zero element in Hn, right? Now number of non-zero element, if I count, suppose 2, 3, 4, whatever, then I have to denote this by m. Once you obtain m, then I have to find m minus 1. Okay. Now you are given some input sequence. You are given some input sequence means input sequence maybe of 10, 12, 14, whatever. Then we will assume some value of n. Now some value of n, what could be some value of n? It could be 4, it could be 5, it could be 6, it could be something. So it will be little more than 4, right? Not less than 4. If less than 4, sometimes it may be the sequence is too small. Therefore, we assume anything more than 4, right? Next, we have to compute the section block. Section block means while grouping the elements of larger sequence, how many points should I take? This is the question. While grouping the elements of larger sequence, which is xn, then how many elements should I choose from the larger sequence for each block of data? For each block of data, that is the length of the smaller block. Okay, that is the length of the smaller block. Okay, so the length of the smaller block, that will be L. Now previously I have assumed some value of n more than greater than equal to 4, say 4, 5, something like that. Now once I have the value of n, which is assumed, and we have calculated the value of m minus 1 in step 1, then I can estimate L using this equation. Okay, once I estimate L, then I have to insert L minus 1 zeros to Hn. Now Hn, previously I have estimated the length is m. Now with L minus 1 0, it has become m plus L minus 1, the length of new Hn with the insertion of L minus 1 zeros. That is step 4. I hope it's all right up to step 4. In step 5, whatever length I have estimated, what is that length? That length is the length of the block derived from larger sequence. Once that length is estimated, then total sequence, larger sequence, may be estimated, may be divided into say 4, 5, 6, 7 blocks, 4, maybe 5, maybe 6, maybe 7 blocks, depending on the length of the sequence. Once I do that, then for each such data, I will insert m minus 1 previous data. Now, from x1 of n, there is no previous data because this is the first block. Then I will insert m minus 1 zeros. Then next block is this one. So I will insert m minus 1 previous data. Now next block again, I will insert previous data m minus 1, previous data m minus 1. Apart from that, the length of L, that is actually the points derived from the larger sequence. Therefore, the new block, which consists of m minus 1 data from the previous sequence, and L is the length of the block. L is the length of the block previously derived. Therefore, this m minus 1 and L, the total will be L plus m minus 1. Now, in that impulse response, that is also m plus L minus 1. With this process, now we are having several blocks. Now, block of data, that length will be L plus m minus 1. Impulse response also L plus m minus 1. So, both set of data x1, x2, x3, x4 and so on and hn, the length of them are same. If the length of them are same, then we can find circular convolution. In order to have circular convolution between two set of data, what we require? We require the length of the data of each signal or each set of signal and impulse response. Both are having same. So with this step, we are having same length of impulse response and each block of data. Now we have to find the circular convolution of impulse response and xi. Xi means x1, x2, x2, x4 like that. So each xi, say x1, x2, x3, x4, x5, x6, x7, whatever be the number of blocks, and these blocks consist of data along with the previous data. Now once I have this xi and impulse response, both are of equal length, then I can perform circular convolution. Once I perform the circular convolution, then we reach into the step 6. Then after circular convolution, we will get y1, y2, y3, y4 and up to say yn or y4 of n, y5 of n, depends on how many data are available. Then once I have all the data, then what I have to do? I have to add, only I have to discard the first m minus 1 value. For each set, I have to discard first m minus 1 value. Remaining data we will write as it is, and that will give you the output. Okay. So I hope you have understood the step, but the thing is that once I take a problem, it will be more clear. Now this example which I have started yesterday, hn equal to 1, 2, 3, xn equal to 1, 2, minus 1, 2, 3, minus 2, minus 3, minus 1, 1, 1, 2, minus 1. Then this impulse response having, first you have to do what? You have to find the length of this. Length of this is 3 because 1, 2, 3, 3 points, m equal to 3, so m minus 1 equal to 2. That is the first step. Second step, xn equal to 1, 2, minus 1, 2, 3, minus 2, minus 3, minus 1, 1, 1, 3, minus 1. Now what I have to do? I have to assume some value n. Let us assume n equal to 4. If I assume n equal to 4, then n equal to 4, L equal to, I have to find m minus 1 is 3 minus 1, then L equal to 2. Okay, L equal to 2. Now, once I obtain L equal to 2, therefore, I have to take two data from each set to form the blocks. Two data and two data from the previous set. For example, if I want to form the x1 of n, x1 of n, I will take 1, 2, 1, 2, but there is no previous data. Since there is no previous data, I will take 2, 0. Okay. Now, next set of data is minus 1, 2. So, minus 1, 2 I will be taking here. Apart from that, 1, 2 from the previous set. Next set of data, 2, 3. Sorry, 3 minus 2, because 1, 2 and minus 1, 2. So, next set of data 3 minus 2. So, next I will insert 3 minus 2 and minus 1, 2 from the previous data. Next, I will take minus 3 minus 1. So, next I have taken minus 3 minus 1 where? Minus 3 minus 1, minus 3 minus 1, and previous data from my 3 minus 2. Next set of data 1, 1. So, what I will do? I will write 1, 1. Now, I will take previous set data minus 3 minus 1 here. Okay. Similarly, next set of data is 2 minus 1. So, next set of data 2 minus 1, I have taken 2 minus 1 and 1 on from previous set. Now, next set of data, again I will take 2 minus 1, but there is no next set, so I will take 2 zeros at the end. So that each of these x1, x2, x3, x4, x5, x6, x7 are of same length 4. This length 4 is required because Hn having the length 4. We are having 3 signal, Hn equal to 3 points, non-zero points, Hn equal to 1 to 3. And in this step, we have said L minus 1 number of zeros has to be inserted. L minus n number of zeros has to be inserted, and L is calculated as 2. L is calculated as 2. So 2 minus 1 is 1. So 1 0 has to be inserted, then Hn equal to 0. Okay. So now I have to convolute of each signal with Hn. I have to find the convolution of x1 with Hn. Now suppose x1
Sir?
with
স্যার বলছি এখানে ধরুন x6 টাতে আমার চলে যাচ্ছে 2 minus 1, লাস্ট টার্মটা চলে যাচ্ছে, তারপর x7 টা নেওয়ার কি দরকার?
x7
এটা তো ধরুন প্রিভিয়াস টার্মটা আর দুটো জিরো আছে।
হ্যাঁ, x7 টা যদি আমি না নিই তাহলে আমার কনভলিউশনটা কমপ্লিট হবে না, বুঝলে? x7 টা
হয়ে যাওয়ার পরও
আরেকটা নিতে হবে, আদারওয়াইজ উই ওন্ট গেট দ্য রেজাল্ট, complete result, because see, you see that if I want to find the linear convolution of these two, Hn and Xn, then how many points it should be? This is 0 to how much it is? 1 2 3 4 5 6 7 8 9 10 11, 0 to 10. This is 0 to 10 na, and this is 0 to 2, so your final output should be 0 to 12. So therefore that you have to do, otherwise you won't get, the next two data will not be available, therefore there will be an error in the result unless you take that. If you don't take this data 1 2 0 0, that is what you say, if I don't take this, suppose x7 I am not taking, if I don't take this, in such a case your two terms will be missing, two terms you will lose in the final result, then the result will be erroneous. Agreed? Okay, so once we solve this problem, that will be more clear. Anyway, this is a valid question, but time being you take this answer as, unless we take these points, result will be erroneous. And what would be the error, that we will understand in due course of the solution of this problem. Agreed? At the time being, what you take, that unless we take this, it will be error in the result. Fine, thank you. Next, now we have to find the convolution x1 of n, h of n. Then what I am writing, I am writing Hn, for Hn I am writing this matrix 1 2 3 0, then 1 2 3 0, then 1 2 0 3, then 0 1 2 3, like that. This matrix I am writing from Hn, and this matrix x1 I am writing for 0 0 1 2. What is x1? You see 0 0 1 2. Now if somebody asks me, sir, I will write for 0 0 1 2 this matrix, and this matrix if you want to write for 0 0 1 2, and this matrix you want to take here, not a problem, that is same result. Have you got the point?
Yes.
Yes.
Then you may ask a question, why sir, then why are you writing 1 2 3 0? The reason being, this part is variable, because x1 x2 x3 x4 x4 x5 x6 x7 they are different, but hn is a fixed in the sense it will not vary, it will 1 2 3 0 always. Therefore once I write this matrix, every time I can repeat the same, is not it? Are you getting my point?
Yes.
In this step, what I have said two things. One is x1 I have written here and h I have written here. So instead of that, you may ask that I want to write x1 here, instead of h I want to write x1 in this format, and h I will take in this format. Not an issue, it will give you the same result. Okay, so then why I have taken, because hn, value of the hn are fixed, whereas this particular matrix, which is x1 x2 x3 x4 x5 x6 x7, they are having different values. So every time I have to write a new matrix if I alter these two, right? Therefore since hn is a fixed kind of data, therefore for h, once I find this matrix, that will be same for all. I need not think much. This is the two things, that's why we have taken in that way. Okay, now if you multiply these two means, how do you do that? 1 into 0, 0 into 0, 3 into 1, 2 into 2, it becomes 7. Okay, similarly you can multiply 2 1 0 3, 2 into 0, 1 into 0, 0 into 1, 3 into 2, 6. Okay, now this is 3 into 0, 2 into 0, 1 into 1, 0 into 6, 1. So 0 3 2 1 means 0. This is 3 0, 2 into 1 2, and 2 into 1 again 2, this will be 4. So 7 6 1 4. Is it okay? All right, this multiplication matrix.
Sir, 1032108 এটা কোথা থেকে আসছে ভ্যালু গুলো?
আরে ম্যাট্রিক্সটা কিভাবে লিখে ওই সার্কুলার কনভলিউশনে প্রথমে
ও
লিখব,
আচ্ছা, হ্যাঁ
প্রথমে 1 2 3 0 লিখব, তারপর একটা নিচু থেকে শুরু করব, 1 2 3 তারপরে 0 লিখব, তারপর এখান থেকে শুরু করলাম 1 2 3 0 লিখব, তারপর 1 লিখলাম 2 3 0 লিখব। মনে আছে সার্কুলার কনভলিউশনের ম্যাট্রিক্স?
হ্যাঁ স্যার,
This
হ্যাঁ
is
স্যার,
the
তো এখানে
circular
মানে নাম্বার নিয়েছেন ওইটা
Method 4.
method 4. Method 4 of circular convolution, hn equal to this and x1 equal to this. Circular convolution in method 4 is what? We have to find circular convolution. Okay, then I have written x1 in this order, sorry, h in this order and x in this order. Agreed?
Yes.
Now I just go to the last. If I take other way, just go to the last page. I have solved that also. Suppose 0 0 1 2, I want to take this here, h is here, then also if you multiply you will get same result. Agreed?
Yes.
That is what I am pointing out, that if you say that no sir, h, why you are writing in 4 by form and x is, instead of h, if you write x 4 by 4 form, and that is 4 by 1 other matrix, then also you will get the same result. So whether you write this matrix in this matrix in this form, or this matrix in this form like we did earlier, both you will get the same answer, 7614. So answer will remain unaltered. So for the advantage what I am getting in doing that I have to have the same matrix everywhere, that is hn. So for this same matrix, again when you compute y2, again you are having same matrix, this one, and this matrix is varying. Then if you calculate this, you will get 2 10 6 6. Okay, this is y2 of n. Similarly, if we compute y3 of n, then this is the matrix, this is thing, again you multiply, you will get this. So this is y3 of n. Similarly, you can do that y4 of n. This is x4 of n. This is y6 of n. y5 I have calculated later. So first I have calculated y4, then I have calculated y6, but y5 was missing, then I have calculated again y5. Anyway, so y4, again same matrix h, data set, then you will getting certain value. y6 also same thing. This matrix H data set is x6, corresponding multiplication you will get this value. This is y5, this is the same data set, and this is the x5, then you will get this value. Similarly, y7, this is the same matrix, and this is the data set for x7, you will get this value. Okay, any doubt if you have so far? No doubts? No doubt. Okay, fine. Okay, now I am writing y1 of n, y2 of n, y3 of n, y4 of n, like this. Agreed?
Yes, sir.
Fine. Now, if I take, you have to discard first two value. Then if I discard first two value, what is the result? 1, 4. Take 1, 4. Okay. If I discard first two value, what is the data? 6, 6.
4, 6, 6.
6, 6.
If I discard first two set of data, port 10. This is port 10.
14.
This is, you discard, you will get 2 minus
2
13.
minus 13.
Then if you discard this is minus 10, this is minus 10.
0.
So this has to be minus, this is a mistake. You correct it, this is minus 10. Okay. Then if you take this data, if you discard, you will get 7, 6. This will be 7, 6. And if you discard this will be 4 minus 3. This will be
4 minus 3.
Agreed? Now,
Yes, sir.
this is how many points? 1, 2, 3, 4,
14.
5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And how many points in this? How many points in this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
11, 12.
11, 12. তার মানে 0 to কত? 11.
Yes.
0 to 11 আর এখানে 0 to HN এ কত? 0 to 2.
2.
তাহলে টোটাল কত হবে?
0 to 13.
কত
0
পয়েন্ট?
to
13. তার মানে 14 পয়েন্ট. 14 পয়েন্টস। তাহলে if we don't take x7, x7 এর জন্য লাস্টে দুটো পয়েন্ট এসেছে।
স্যার
হ্যাঁ
স্যার
হ্যাঁ
স্যার স্যার
হ্যাঁ।
এক্সেন্টে 11টা আছে।
হ্যাঁ 12টা আছে, দুটো এক আছে ওখানে।
দুটো এক আছে?
11 না।
1
এটা দুটো এক। আচ্ছা আচ্ছা
হ্যাঁ।
ঠিক
ঠিক
আছে।
আছে, দুটো এক আছে। তাহলে টোটাল your point will be has to be কতগুলো পয়েন্ট হতে হবে? 0 to
0 to 13.
14টা পয়েন্ট হতে হবে, 14টা। So you are required to have 14 points in the signal, output signal or the output. Now if we don't take x7, then what happen? Last 2 points will be missing. If we don't take x7, then if you don't take x7, then there will be no y7, right? There will be no y7. If you don't take x7, then there will be no y7. If y7 is not there, then what happen? This 4 minus 3, these 2 points will be missing, is not it? If there is no y7, then 4 minus 3 will be missing. So if 4 minus 3 is missing, then you will be short of 2 data. You are supposed to have length you are supposed to have 14, is not it? Because your input is 0 to 11 and impulse response 0 to
2.
So if you add the lower limit, it will be 0 plus 0, and upper limit means 11 plus 2, so it will be 0 to 13. 0 to 13 means it is 14 non-zero points in the signal, or 14 points in the signal. Okay, 14 different value on the signal. So unless you take x7, you don't have y7, and therefore you will be shortage of data as far as last 2 digit is concerned. Okay, now you find the linear convolution. You have to find the linear convolution. I mean, let us see 1 2 minus 1 2 3 minus 2 minus 3 minus 1 1 1 2 minus 1. That is as we have given the data in the problem. This is your xn, this data and this data hn, for which I am finding the linear convolution. Okay, now if you find the linear convolution here, see, 1 into 1, this is 1, this is 2, minus 1, this is 2, this is 3, this is minus 2, this is minus 3, this is minus 1, this is 1, this is 1, this is 2, this is minus 1. If I multiply by 1, then if I multiply by 2, this will be 2, this is 4, this is minus 2, this is 4, this is 6, this is minus 4, this is minus 6, this is minus 2, this is 2, this is 2, this is 4, this is minus 2. If I now multiply by 3, this will be 3, this is 6, this is minus 3, this is plus 6, this is 9, this is minus 6, this is 3 into minus 9, this is minus 3, this is 3, this is 3, this is 6, this is minus 3. Now if I take the points, first is 1, then 4, then this is how much? 6, 3 plus 4 minus 1. Then this is 6 plus 2 minus 2, this is 6.
6
Then this is 7, 7, this
4
is how much? 4.
4 হবে না 4
Okay, this is 6 plus 6 minus 2, this is 10. This is 9 minus 7, this is 2. And this is minus 6 minus 6 minus 1, this is minus 13. This is 6, okay, this is minus 9 minus 2 minus 1. So this will be equal to
minus 10
minus 10.
minus 10
So this is correspond to minus 10, and this is 0. This is correspond to 3. This is plus 3 minus is 0. Next one is 2 to 4 plus 3. This is 7. Then 4 plus 3 is 7. 7 minus 1. This is equal to 6. Then 6 minus 2 equal to 4, and this is equal to minus 3. Then if you compare this result and this result, these identical. See, 1 4 1 4 6 6 4 10 2 minus 13 10 0 7 6 4 plus 3. Now if you compare this result, they are identically same. They are identically same. Therefore, this solution agrees with that. What you have found in using overlap and same method. Okay. So the point here is, when you are having overlap and add method, then we are adding the overlap, and in this we are discarding the overlap. So at the overlap, that value we will discard or we will not take. Rest of the value we will organize one by one, and that will be your y of x. So essentially what we have done here, we have computed linear convolution, right? Essentially in this problem we have computed linear convolution using circular convolution. Is not it? Essentially we have performed 7 number of circular convolution using linear convolution, and the total result linear convolution and in this process is same, right? Now this method is due to for longer sequence, right? We will not follow this method for smaller sequence. We will follow this method only for longer sequence, for requirement of when the storage is requirement is more and the data may not available immediately. So major idea behind these two methods is for computer based solution and processing, not that pen paper solution, right? For pen paper solution, what we do, this method is much simpler than this. We can compute with no time, where this method requires lot of time to compute, right?
স্যার তাহলে এখানে ওই আগেরটার মতো একটা যেমন ছিল লেস টাইম ডিলে, এখানে তো টাইমটা তো বেশি লাগবে।
কেন বেশি লাগবে? সমস্ত ডেটাটা ধরো, সমস্ত ডেটাটা তো একসঙ্গে অ্যাভেলেবল না হতে পারে। ধরো ডেটা স্ট্রিম আসছে, কিছুটা ডেটা অ্যাভেলেবল হলো, তো সেভ করে কম্পিউট করে দিলে, মানে ধরো টোটাল হয়তো এই ডেটা আমরা যেটা 10টা 12টা 15টা কথা বলছি, দ্যাট নট লাইক দ্যাট। দ্য ডেটা মে বি 10,000 per second. Data may be 1 mega means 10 to the power 6 per second, like that number of data. I am not being able, it is not possible for me to solve 10,000 data, is not it?
Yes, sir.
So I am giving an example of 12, 14 data to understand what actually happening inside, is not it? Basically, overlap add method and overlap save method, that is essentially for very large data, very large data. But I can give example only 10, 12, 14 data, not more than that, because I have to write this in one page now. Entire thing I have to calculate within a page. So for us, we work with 14 data, is not it? But the major advantage out of this, what is the major advantage out of this? Suppose all these data are not available. Suppose four data points. Once 4 data points available, we'll start computing, right? In this process. Next, once, because computation requires few seconds, few nanoseconds maybe. Modern days VLSI technology, you require nanosecond delay of the gate, and within 1 nanosecond data will be available. But computation also requires some time, right? So that computation time, other data will be available. In this process, we are saving the delay. At the same time, another important thing I said, we can say memory. Memory in the sense, suppose 10,000 data is available at a time, slow by slow, and you are storing the data first. Then that storage will be wasted, is not it? Suppose the
Yes,
data available, you compute and leave the data. Data is available, leave the compute and leave the data. Ultimately, you need the output. You don't require the data. Once I obtain this result, ultimately I need the result. We don't require this data anymore, is not it? Therefore, we
Yes.
save the storage as well. So this is the major advantage of these two method over conventional method. The thing is that conventional method are the fundamentals. On the basis of that, other methods are developed. Right? When we are studying the further part of the DSP, all are building fundamental building blocks. They are having, all are having some fundamental building blocks. And as far as this DFT section, when the almost we are completed, we are on the completion of DFT section, right? We are almost, maybe one more lecture I will complete DFT and we will switch on to FFT. What I am pointing out, whatever be the advanced stages of DFT or digital signal processing that develop, that all depends on fundamental things, right? With the DFT completion, even overall, like overlap add method and overlap save method, they are the advanced computational techniques, but they are essentially based on fundamental concept of convolution, either linear convolution or circular convolution, right? Unless you know this, you cannot compute in overlap add method or overlap save method. So that is on the basis of fundamentals. With respect to DFT completion, chapter of DFT, all fundamental aspects related to this course will be completed, right? Rest of the portion of the course, right? Rest of the portion of the course means what? FFT. FFT I will start probably next week. This week one more class I will be concentrating on some problem of DFT or property. So next week we will start FFT. That is nothing but computation of DFT only, right? But using some algorithmic approach. Okay. So next week we will start FFT, but next Saturday I will discuss some more problem and maybe some more properties if left, that I will discuss. But all fundamental aspect so far almost completed of this course, right? So next we have FFT, is the one of the important chapter. Definitely there will be one question. And overlap add method, overlap save method, you may have numericals. At the same time, you may have short notes, right? So short note point of view, what you have to do, you have to write the theoretical part. You may give the example, may not give the example. And in case of problem, then only you solve the problem as I have given you 2 examples, 3 examples so far. And another important thing, that as far the course is concerned, I am left with 2 topics essentially. One is FFT, another one is filter design techniques. Filter design techniques, since you have long time, how many classes we left, do you know? So till
no, sir.
how many
No,
classes we have? Still, how many classes
স্যার
we have?
জুন 13 অবধি তো দেখতে পাই ম্যাকআউট পোর্টালের
Acha,
রেকর্ডে
June
আছে।
13 months means what? 2 weeks in June.
হ্যাঁ, আর
And
ফুল
May,
6
মে
weeks,
6 weeks. 6 weeks,
6টা,
how
হ্যাঁ
many
6টা,
classes?
24 চারটে করে
24টা ক্লাস।
Minimum
চারটে করে
20,
হচ্ছে।
no, minimum 24, 25 classes we have. Right. Now, if you look at the syllabus point of view, we are having two topics. One is FFT, another is filter design. So naturally, we may revise the course also because we have a lot of time. That much of time may not be required for this course. All right. And also, one more thing I want to tell, I might have covered overlap add and overlap same in same class in regular classes, right? Now we have taken 3 lectures for that, right? Also regular class of 50 minutes and this is 40 minutes, that is different thing. So in regular classes I covered both of them in one class, right? Because this time onwards when classes comes around March and April, then time is very less, you know, so I have to cover the things little faster. So essentially I require lesser class, but I am taking more classes, so things are going slowly. So 24 classes means, as I have planned, we required 6 to 7 lecture for FFT and 10 to 12 lecture for filter design. Then we will start revision. Okay, so revision of the previous course. Okay, so if you have any doubt regarding these two, you can ask. Otherwise I don't have much time left. Tell me if you have any doubt. Overlap add and overlap sub method. Any doubt?
No.
No doubt?
Sir, what is the drawback of overlap add method when we are using overlap save method?
Overlap save method and overlap add method, if you compare these two methods, the main drawback in this method is, suppose in overlap save method we are computing this but we are not considering this, right? We are computing but we are computing this data, right? We are computing this data but we are not using this, so that data is not useful. But in overlap add method, whatever we compute, all data are useful. So drawbacks of this overlap same method only, that some of the computation data is of no use, right? And
So memory is being wasted.
memory is being used, but this is not useful. But in overlap add method, whatever memory is used and everything will be used in the entire final answer. This is the one thing. And second thing, that is the drawback in overlap same method, that two data every time I have to get from previous data, right? So two data shifting from the previous data, it requires some operation, that is some shifter, right? Some shift register are required. That means we require little more hardware in overlap same method. That is also another drawback, because this whenever there is an additional operation that requires additional hardware, and that will increase the cost. Is not it? That is the drawback in overlap same method. So one is some computational data which is obtained through computation. At the end of the day, that is at the end of the computation, no use. And at the same time, having the data from the previous data set, we require certain shift register or some memory for getting that data from there. Some shifter is required. So for that also we require additional hardware. So it will be little more cost here. Is not it? Third, another, if you look at the computational point of view, circular convolution involve larger computation compared to linear convolution. These are the three disadvantages in this method, right? Because circular computation, you need higher computational complexity, little higher. Agreed?
Yes.
So I hope it is clear. If you have any doubt, you can ask. Anyway, it is less than 1 minute I have at this stage. Okay, I hope you have no doubts so far. Okay. Okay, then next we'll meet in Saturday. Okay, Saturday we'll see what, if I solve, may I solve two more questions. Okay, 1 or 2 more questions.
Okay, sir.
Okay, fine. Until then,
Thank you, sir.